In general, when we are planning to build a robot, making the 3D design using CAD software like SolidWorks is a much needed thing to do. Because after completing all brainstorming sessions, we usually came up with our finalized idea by merging our all ideas. So we have to know exactly whether the finalized idea is feasible or not. When we design, we should be aware of the exact dimension of each and every part, like even nuts and bolts. Then we can see and adjust the placing of the components by considering the factors like the center of gravity and use fewer wires for wiring. For example, the battery may be the heaviest component in the robot. So we have to place the battery considering the both factors of the center of gravity and minimizing the wiring. Also, we need a 3D design to realize the dimension of the PCB and how the components are placed on it. And we can simulate and see the behavior of our designed robot arms and their feasibility. When it comes to our design, we did our design using 4 steps. The first one was collecting some basic 3D design from the internet. There are some famous websites like GrabCAD and 3D Central. And my second step was draw all the necessary parts separately using SolidWorks. And the third step was making sub-assemblies using that parts. For example, I built a coin unloading sub-assembly and also a combination of motor, wheel and motor bracket and encoder sub-assembly. My fourth step was make the final assembly using all sub-assemblies and parts. Also, you can find there are more tools available in SolidWorks, like we can simulate and calculate the center of gravity of our design. Now we will bring you some features in our robot. Robot unloading mechanism. This was a critical situation because we had some various set of ideas to carry and unload the robot. After lots of discussions, we have decided to have this kind of robot carrying and unloading mechanism. And this mechanism is one of the reasons to be the best robot design in the competition. We carry our secondary robot on top of our primary robot. When we unload our secondary robot, we use thickness of 3 mm acrylic board along with low friction hinges. We used link mechanism powered by a MG995 servo motor to move the board, and we sharpened the edge of the board to get the smooth delivery to the arena. Efficient mapping mechanism using 3 color sensors. As you can see in the video, our robot does not go through each and every path of the maze. It goes on the one line and then skip the next line and directly goes to the path next to the skipped path. This is possible because we have used 3 color sensors to detect the paths in the maze. Here, the middle color sensor is sensing the color on the path where the robot is currently moving, and the right and left color sensors detect the colors of the left and right squares when the robot is passing a junction in the maze. Because of this, we managed to save a lot of time in the maze. Coin unloading mechanism. Our coin unloading mechanism was very unique and unbiased. We were able to unload any coin at any time without calculating the unloading order before the task began, and put coins according to that. This was one of the best coin unloading mechanisms in the competition. The mechanism worked with two servo motors, one for selecting the required coin for the movement and another one for opening the door to drop the coin. Also, the best part was the rack and pinion mechanism we used to unload the coin. Placement of robot wheels. We decided to bring the wheels of the primary robot at the center due to it having to carry another robot on its top. So, we should consider the center of gravity when it travels with its primary robot. So, we realized that it is better to have the wheels on the center because it makes us to make all the turns perfectly without changing its axis and positions. This makes us to control the robot in a very easy manner. Robot arm design to grab the box. We wanted to design a very simple and small arm to grab the box and move it properly. So we came up with this kind of design. These kinds of triangular edges help to grab the box properly. And we have used a thread bar and link mechanism to control the arm because the servo motor is placed away from the arm.
For the purpose of reducing the external connections through wires, we designed a double-layer PCB for the robot as a base platform in a way where we can plug all the external components to it easily. Here you can see the schematic of the printed circuit board of our secondary robot. Here you can see the top layer and bottom layer of our secondary robot's PCB. In fact, we made our own component library with 3D models of the components so we could finally complete the PCB with a full 3D model as you can see here. Because of designing a complete PCB to connect all the components, we could finish the wiring stage of the robot in a proper way and there were no issues because of any loose connections of wires. But we faced one issue at the first stage as there was a connection between the PCB's ground net and the external cover of the metal gear motor. This issue occurred as we have mistakenly put the copper core very close to the nut holes of the PCB. A small scratch made by a nut was the reason for the connection between the motor and the ground net of the PCB. In fact, we isolated power nets of the robot using a 7.4 volt LiPo battery with a buck converter and a boost converter. So we could give power to 12 volt motors without any risk of damaging other components of the robot.